Hey, what's going on, folks? It's Mike here, and welcome back to the Deep Programming Language series. In this lesson, we're going to talk about compile time sequences, which really enables a lot of the cool and interesting metaprogramming and compile time programming stuff that you can do and that we've been talking about in the previous lessons if you've been watching and subscribed. So anyways, with that said, let's go ahead and check out the article, and then we'll dive into some examples of how to use this AliasSeq compile time sequence programming tool. Alrighty, so let's go ahead and go to the documentation, and I'm actually going to take us to articles first here, so we can actually see how this tool works here. And if you scroll down a little bit, there's a really nice article that's been written by some folks in the community on compile time sequences here. And this really shows how to, or rather gives the background support for doing things like variadic templates that allow you to operate on type, symbols, and values at compile time. So again, really powerful feature here. And also enables things even as simple as writeLine, for instance, to have multiple template parameters, which is ultimately what you're sending in there when you specify each of the different arguments. So there are some interesting thoughts, even just starting with the idea of compile time sequences. A lot of folks will call them just tuples. I don't think they're exactly the type of thing known as a tuple here. Again, I think I'm not going to get too stuck on the name here. Compile time sequence, I think, is a fairly safe way to call these things, or otherwise for an alias sequence here. That is basically just to say that we have a collection. You can think of it like a array at compile time that's fixed in size, for instance, which is, again, sort of what a tuple is like. That's, again, the confusion with the name here, but that's the basic idea. So anyways, the basic idea is if we have something like this, where we have some template, whether it's a function or a struct or a class, which we haven't looked at classes yet, but operates the same as structs in this case, that basically here for this T here, we can have any number of arguments. Well, we need to be able to store those somewhere. And we can treat them like a sequence. So you can think about this like a mathematical sequence, for instance. And I can take you to my drawing board just to make this, simple enough. But if I have something like last time we talked about having a print function with the arguments here. So T is, again, the sort of data type, if you will. This is like the data type, which we're finding out is this thing known as a compile time sequence. And again, we're going to use it as also, alias sequence here, okay, which is basically just a collection of things. So again, you can just think about that type as a collection of the parameters here. Okay, now we're thinking about things as a fixed size here. So let me go ahead and just say, 1, 2, and 3. They could be values. They could be types themselves. So we could have, int, and int, for instance. That's the basic idea, just a holder at compile time of what we have here. Okay, so that's all we're saying here. As you read through this article, you're going to find out, again, you can have values in a sequence, you can have types in a sequence, so there's different types here. But this is the basic idea here for how AliasSeq is implemented in the actual language here. Again, it's a templated type here. So again, just a variable number of things here, and then equal to, whatever the collection is here. So it's most useful to look at some examples here. And this is going to come from the meta library here. We'll open that up in a second here. The basic idea here is that you create an alias. So again, this is something that's known at compile time, and then you can have some combination of types and values here. Again, so at compile time, you can see where we're doing the pragma and the message here. I get the name here. Let's make this a little bit bigger here so you can follow along. The int, and then 42 here. Okay, so that's the basic idea here. And again, all this information is known at compile time, so you use it with compile time features as such. If you watched the last video, you can see how you could use this to iterate through a sequence or some collection, and then basically do all the things that you do as we go through here with fixed size arrays, like check the length, for instance. You can index and slice into these, so that's really cool. So these are all things that we already know about, and we don't really have to learn a new sequence or a new syntax, excuse me, to use the alias sequence. So that's a really kind of interesting idea here. You can also do some interesting stuff, like if you have a variable, for instance, at compile time, again, is where you're working with this. You can generate the instruction that says, hey, look at this variable here, because you can store variables that are known, again, at compile time or within scope here. and have those assigned, right? So sequence of 1 here is effectively just replacing x here, and then we could just check if x is 42. So some interesting stuff here. I'm going to preclude this next section, for each or static for each, or we probably want to use this as, again, iterating through the sequence of symbols here. That's the basic idea here. So let's go ahead and play around with this idea just a little bit here. Just as a quick refresher, let's go ahead and grab, I'm going to grab this from the previous video here. Let's see, what was that, video 99 or so, or video 92, one moment. Yep, let's just go back a directory here. So if you didn't watch this video here, basically what we did here is we wrote this little print function. I'm just going to grab this. Let's grab both of these static print functions, just so, again, you can take a peek or use them as a reference here. I'm going to go ahead and add, for our imports, let's add in standard input output and meta so that we can use the alias sequence instructions here. And again, we'll keep an eye on these. So again, let's just start off simply by creating an alias. I'm just going to call this sequence here, alias sequence here, and let's just put in an int, a double, and a float, something like that. Make sure that we're working so far here. I'm going to use DMD to compile these just so it's a little bit, at compile time we can see what's going on here. So this is it. This works just fine here. We could do pragma message. Let's print out that sequence here. Let's see what it gives us at compile time. And we can see that we've got an int, a double, and a float that we can work with and start transforming data here. So where this kind of starts getting interesting too is, let's say if we have some sort of struct here, some type here that has an int, field 1, let's call it, a double, field 2, a float, field 3, something like that here. I can actually, again, use these pragmas here, and I can get this type a tuple of it. Let's see what I get here. If I do this, I think it's work. Oops, let's see what I did. And it's saying this interesting error message. It's saying error variable field 1 cannot be read at compile time. Cannot be read at compile time. Cannot be read at compile time. So it's just telling us, let's see, you've got this sequence of error, error, error here. It just doesn't know the actual values here, right? So this isn't working here. So instead what we could do here is, again, just, using these little tricks here, we could say alias, type sequence or something equals, and then we could use this little trick here, type tuple of, and then let's actually do the type sequence here. And oops, let me make sure I save this. And if I run this, I'm gonna get the same, error message. It just depends on what we want to do with this here, right? So same thing here. But what I just want to actually do in this example here is just hold on to this tuple here, right? It's complaining about line 28 where I can't write this out here. But what I can do here that might be interesting is to actually, if I just want to, get the actual fields of here, string of, which we could have done previously here. And you can see the actual fields, field 1, 2, and field 3 here. And let's take a little bit of a detour and see if we can find some interesting things here. I'm going to go ahead and let's open up another page here. I'm going to go to the library reference here. Let's go to, I think we did something like this similar before. We went to traits here, where we can extract information about types and symbols at compile time here. Okay, so this is kind of interesting here. Let's see if we can find like fields or something. I believe that's what it is here. So aggregate type traits. So wherever we're aggregating a type, that would be something like a struct or a class here. Let's say with fields. And basically what we could do here, we could see this little example here. Let's see if we can kind of replicate it. But basically the idea here is to, we could see the fields trait here. When I'm looking at this struct here, I can check and see, well, are these the fields here from the struct here? Does it consist of a integer and a float here? Okay, so that's kind of interesting here. We also have field type tuple. That's an alternate name for fields for compatibility. I probably also want field name tuples here. So let's just work with fields and field name tuples, just kind of going off script here. But want to, just show you some stuff that's kind of interesting that you could do for the meta programming. So let's make sure that we add in traits here. And what do I want to do here? Let's just start with a pragma here. So let's do pragma message type, or we want fields of type. Let's see if that'll give me what I want here. Let's see, that's going to give me int, double, and float here. And then we want pragma message field. I got to look back at the name here. Field name tuple, okay? Which again is giving us this alias sequence here. Field name tuple. And I want to do this for my type here. Again, all the trait stuff you could do at compile time. So again, I can see I've got the field 1, field 2, field 3. And again, when you see this being written out, you see that they are alias sequences, the same thing that we are creating here. So this is pragmatically where, again, I start with this stuff, where you're probably going to start with it, where it's useful for just doing some introspection on types here. So again, it's a little bit of a challenge here. You can go ahead to the traits library and just start, asking questions about different data types at compile time. And sometimes if you're looking through fields, or let's see what else we could do. Member functions tuple. This one might be kind of interesting here. And you'll see why some of this introspection stuff's interesting. Again, another interesting case is when you have template constraints. So when you're doing generic programming, you might want to say, hey, does this have a compares member function or a hash members function or something? So that's where these things are kind of useful here. Let's use the member function tuple here just to see what's going on here for our type here. Let's see here. I haven't actually used this member functions tuple. Okay, so we see returns a tuple of non-static functions with the name declared in the class or the interface. Okay, so let's go ahead and see member function tuple here. Let's see what we get here. And it says that it works with a class or an interface. I wonder if it works for a struct here. Let's actually see. There might be a different function for that. Message, and again, member functions tuple for type. Let's see if that works here. Let's see here. It says does not match template declaration here. I think it does have to be a class type here. Let's see if we can find one for structs here. And I want to look for like members. Oh, a new members might do the trick here. Retrieves members of an enumerated type. Oh, let's see here. Nope, that is just for enums if I scroll down here. So let's go ahead and try again here. And again, this is just how you play around with it. Again, I want to do a little bit more live coding with this here. Let's see if we can find it for each of the struct. And I'll actually just give you a little hint. I have researched this before, and I have some code here. So let's copy that out here. What we want to do is just use these traits here, and we have this all members here that we can actually use for our type here, this struct. Now we should actually probably give it some function here called like void print, and it's not really going to do anything. Let's just see if that pops up here. And let's make sure that we can see this here. I think I've got that out right here. Whoops, I've just got to make sure I get the right number of right parentheses. Always the hardest problem, but now we can actually see all the members here. And I think we could further filter this. But anyways, you get an idea about how some of this, these alias sequences with traits are kind of useful. And you can see if there's a print function or whatever that you need, or it implements, or could do these types of checks at compile time, and so on and so forth. So anyways, what I want to get to next here is this other idea that sometimes we want to create a alias sequence here. And let's go ahead and keep moving forward here. Let's call this sequence 2 here. And I want to create this alias sequence, this time of numbers here, just a few of my favorite here. Let's make sure that this works fine. Oops, I got to call this something new, sequence 2, there we go. So this works just fine here, right? No compile errors, we can add this, no problem here. But what if I want to do something like take this and sort it? So let's go ahead and try that here. And it says no property sort for this sequence, int here. Okay. So what do we do, or how do we treat this? I mean, is there a way? Because this seems like it would be interesting if we could sort of generate these sequences at compile time using mix-ins or otherwise to generate some sequence like this, and then sort it. Sort itself is already pretty powerful. I mean, it'll work on compile time stuff, but how would we get this to work here? Well, what we really want to use here, and let's go to our documentation here. We're going to go to, instead of traits here, we're going to go back to the meta library here. And let's see what else we can find here. We've got our building blocks. We've got alias, which is just sort of good for one type, a sequence of types, and then we've got this alias sequence of here, which converts any for each iterable entity an input range to an alias sequence. So that's kind of interesting here. Let's see what we can do here. I mean, already we see there's some interesting stuff here. Again, this is where I sort of cheated when I was preparing for this and found the all members thing here. But then you could actually sort it and capitalize everything. Okay, so that's kind of interesting. So let's see if I could just take any sort of general set of arguments here and actually just sort them if I use alias sequence of. Okay, so it's sort of like a function because it's returning an alias sequence. So alias sequence of, lowercase at the start here. Let's just try that and see if that works. It's getting closer. It says it does not match the template declaration here. Okay. And again, remember what it's thinking about here. Are these three comma separated things? Is this something that I could put in a for each loop here? Well, let's try it. For each element 42, 5, 70. Okay, let's see if that compiles here. No, this is complaining and giving us, some weird stuff here. Oh, probably because I messed up the right parentheses. Yeah, it's still complaining here. It's saying, it's not the quite aggregate type. We don't really have a notion of a tuple here in the language. But what is iterable? What if I made this into a slice or a dynamic array? Okay, so that looks better to me. That looks like it's not at least complaining about this piece of code here. So again, if we just reason about this, and I have something like this, and again, I put it in the brackets here, this is looking better to me here, okay? Now, I can't call .sort on this here quite yet, but what I can do is go inside the parentheses here and call sort, okay? And let's see. That should do the trick here. Now it's just complaining about, and again, D usually gives pretty helpful error messages. I just need import algorithm here, okay? So that should do the trick here. And now I have this second alias sequence where I can sort it, I can run a map function on it, and so on. So let's just go ahead and observe sequence number 2 here at the very end. And we should have this sorted, 5, 42, 70 here. Okay, 5, 42, 70. Okay, so now I can generate alias sequences that anytime I'm generating some, set of data here. And again, you could do interesting stuff here. Let's sort it, and then let's call map here, and then let's do a lambda function here. I'm just gonna take an int x, and then I'm gonna do here. We're gonna have to make this a little bit bigger here, like x times x or something. Let's see if that does the trick here. I think that's gonna work for us. And there we go. We've just doubled everything. So now it's 25, 1764, and 4900. Whereas before it was 5, 42, and 70. So again, you can kind of compose an interesting alias sequence here at compile time. So these are the two to know here, this alias sequence of and alias sequence, and to know that this is really our tool when we're working with templates that gives us that superpower for variadic templates and doing a lot of the different compile time programming. So again, we have covered, just to do a little bit of a recap, if we go up to the top here on our meta programming here, the basic building blocks here, okay? And again, we could do other interesting things like filtering and so on, and check the length and get elements and so on. But anyways, these are just a few of the built-in things here in the D programming language. So folks, with that said, there's all sorts of other interesting tools and fun examples I could think of, but I just got to show you the building blocks. Of course, you should, probably track your progress and practice along with me, and you can do that on courses.m.io in the D series or my other courses here. If you find those useful, I'll go ahead and leave this code up here just to scroll through one more time because I think it's fun. Again, we've basically uncovered how this works now, giving us that compile time sequence. Similar idea when we did this with structs in the previous lesson. And again, you can see here it is alias sequence that you can create with the alias building block here. You can start doing interesting things immediately, especially with the traits. That's probably where you're going to start using this stuff if you want to do more generative programming. And then you've got alias sequence of, which will convert something that is a range, or otherwise you can just think of it as something that's iterable that can go in a for each loop. And then operate on that and get an alias sequence back at compile time. Okay, so that's the summary. Hopefully that's useful for you, and hopefully you enjoyed that. So anyways, folks, with that said, thanks for your time and attention as always. I'll be really curious if you've used these particular tools in different ways, have some cool concrete use cases that you want to share with the community. That's always useful for folks. Again, I've used this for generating data structures, generating sequences at compile time, which is sometimes interesting to do, but there are plenty more use cases that you could think of. Anyways, folks, with that said, I'll let you go, and I'll look forward to seeing you in the next video.